Dear Selection Committee, we are Rohit Kati and David Hansen from the Erasmus Mundus Joint Master, Copernicus Master in Digital Earth. We present to you our outcomes of this year's hackathon. Our aim was to use the land cover AI data set to fine-tune a model that could be deployed for quick response situations like floodings and earthquakes. We think that the land cover AI dataset includes the most important classes for these situations, this being roads, buildings, and water. And since the main data source, or one of the main data source for in these situations, are aerial images from airplanes or drones, we think that the fine-tune of an Earth observation foundation model would be very beneficial for these situations in order to allow faster allocation of resources for we tackled the problem with two foundation models. We did experiments on the Settlers pre-trained models. That is pre-trained on aerial images because of the more fitting data source. And we used the Prithvi models. And after comparing the results between the two models, we stick to the Prithvi model, the foundation model, and fine-tune solely on this. This led to our Prithvi4QR model that is now presented by Rohit.
After comparing the two different foundation models, the Prithvi and Satlas, we decided to go with Prithvi. So in Prithvi, we decided to change the decoder to ApperNet, and we tried to we tried to counterfeit the class imbalance by using the sufficient class weight to each of the classes. We had a lot of backgrounds, so we provided less weight to the background and more weights to the building and road. So once we finalized the different once we trained on the different class weight, we finalized this sequence of the class weight. Then we decided to train our foundation model for 50 epoch. So when we did the test, we got these matrices, which was when we analyze this in chart, we can see that our losses are decreasing along with time. If we train this for more epoch, then it will definitely be a better fine-tuned model. We can see the curves for Jacquard index, which represents the IOU. We can see the IOU for background is too high. This is because of the huge inclusion of background class. Our next step in this domain will be to increase the data augmentation process to include a more sophisticated data augmentation, so that we can capture more details from the data sets. Also, we were planning of implementing the LoRa to decrease the amount of parameters that are used to be that are used in the fine-tuning process. So this too will be our future this could be the future implementation in this project. So this is all that we performed in our project, and this was a great experience. Thank you.